In this lesson, we're going to look at some more difficult applications of the chain rule. Before we do that, though, I want you to pause the video and try to take the derivative of this function that's given on the screen. Okay, to take the derivative of this, you should have used the quotient rule. So we're going to do low d high minus high d low over low low. So the bottom times the derivative of the top, which is 1, minus the top times the derivative of the bottom, which is 1, over the bottom squared. Okay, now normally we can stop right here and we don't have to simplify. I'm going to use this for something else in a second, so I just want to make sure that we can simplify it to make it a little bit easier for the next step. Okay, so if I distribute here in the first part, I get x plus 1 minus x over x plus 1 squared. I'm not going to multiply out the bottom, but this simplifies to 1 over x plus 1 squared. Okay, just a review of the chain rule. Okay, so the reason why we did this first is because we're going to now do the derivative of this function, which is the tangent of x over x plus 1. Okay, now the one that we just did a second ago was the derivative of this part right here in the middle. Okay, and we found out that the derivative of that was 1 over x plus 1 squared. Okay, I'm just going to put this over here on the side. Okay, so for this particular problem, we're going to have to use the chain rule. Now, the inside function is x over x plus 1. Okay, the outside function is the tangent function. So when we go to take the derivative of this, we're going to do the same thing we did in the last lesson. We're going to take the derivative of the outside with the inside left alone and then multiply by the derivative of the inside. So the outside function is the tangent. The derivative of the tangent is the secant squared. So there's the derivative of the outside with the inside left alone. So it'll be x over x plus 1. And remember that I told you the other day that the angle in the original problem has to be the angle throughout the problem, even if we take the derivative. So it's still x over x plus 1. So here's the derivative of the outside with the inside left alone, but I need to multiply by the derivative of the inside. Now, if I didn't already know the answer to the derivative of the inside, because I did it on the previous slide, I would have to use the quotient rule right now and take the derivative of the inside. So I would go through the whole step and say low d high minus high d low over low low. Now, I already did that, and I already know that it simplifies to 1 over x plus 1 squared, and so I'm going to go ahead and just write it over here on the side. Okay, so this is the same process that we used last week, but now in addition to the chain rule, we actually had to use the quotient rule to find the derivative of the inside. Okay, now if this were a multiple choice question, they probably would take this first part over here and treat it like it were a fraction over 1, multiply it by this one over here, 1 over x plus 1 squared, and the answer would probably look like this. Secant squared of x over x plus 1, and then bottom times bottom would be x plus 1 squared. Now, this is probably a little more complicated than most of the problems that you'll see, but you will be required to use the chain rule in conjunction with the product rule and the quotient rule and all the other rules that we've used. All right, so let's take a look at this one. For this one, the inside function is t squared over t cubed plus 2. The outside function is squared, this part up here. Okay, so if I'm going to take the derivative of this using the chain rule, I'm going to do the derivative of the outside. Okay, so the 2 exponent comes down in front and the exponent decreases by 1. Okay, there's the derivative of the outside with the inside left alone. And then I have to multiply by the derivative of the inside. So now to find the derivative of all the stuff that's in yellow, the inside, I have to use the quotient rule. So it's going to be the derivative, or I'm sorry, the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. Okay, if you want to try and simplify this a little bit, we're going to have 2. This is going to be t squared over t cubed plus 2. I don't need the exponent of 1. Okay, Okay, and over here I could distribute. I get t cubed plus, or t cubed times 2t to the fourth, plus 4t minus 3t to the fourth, and then the whole thing's over t cubed plus 2 squared. Okay, we actually could keep simplifying further. I can collect like terms here. I could actually go ahead and multiply these two fractions together. I could put the 2 up here on top. Okay, but you're not going to have to simplify these for me. And the ones that are multiple choice are probably going to be easier for you to find the right answer than this one right here. Okay, this is more typical of what you might see for an AP multiple choice question. Okay, so when we look at this, what you need to realize is we're going to have to use the product rule because you have x times the cosine of 1 minus 3x. Okay, so these are where they start to get a little bit complicated. People aren't sure whether they should use the product rule, quotient rule, or product rule. If they even need the product rule, do they need the chain rule? Where do they need it? They apply it to the wrong places. So you need to understand that this equation right here is the same as x times the cosine of 1 minus 3x. Okay, so we're going to use the product rule. This is the first factor. This is the second factor. The chain rule is going to come into play because when I take the derivative of this part over here, it is not just the derivative of cosine of x, but it's the derivative of the cosine of 1 minus 3x. Okay, so let's go through this. Derivative is going to look something like this. The derivative of the first, I'm using the product rule, derivative of the first is 1 times the second, cosine of 1 minus 3x. Notice I'm not taking the derivative of this part, it's just the derivative of the first times the second. Remember the product rule? Derivative of the first times the second plus the first times derivative of the second. So this is f prime right here. This is g. Okay, plus, now I need the first, which is x. That's my f. And now over here, I need g prime. So now I need the derivative of the cosine of 1 minus 3x. Well, here's where I'm going to need the chain rule. The derivative of the cosine of 1 minus 3x is derivative of the outside, negative sign, with the inside left alone, times the derivative of the inside. The derivative of 1 minus 3x is negative 3. And so all of this stuff right here is the derivative of the cosine of 1 minus 3x. Okay, now if this were multiple choice, let me show you what they do. You've got 1 times cosine 1 minus 3x. Okay, that's just cosine of 1 minus 3x. Okay, over here, you've got negative in front of the sign, and you've got a negative 3, and you've got this x out here in front. So you've got x times negative 1 times negative 3. That's going to be positive 3x. And then it's going to be times the sign of 1 minus 3x. If this were multiple choice, that's what the answer would look like. Okay, let's take a look at this one. Sometimes the trig functions are the outside functions, but in this one, the trig functions are actually the inside functions. Okay, so this one, if I want to rewrite this, I'd probably want to write it as sine cosine to the 1/2. Okay, now this one's going to be tricky because not only is it sine cosine on the inside with the 1/2 on the outside, but when I go to take the derivative of the inside, I have two things multiplied together, and I'm going to have to use the product rule. Okay, so let's see what this looks like. Okay, derivative of the outside with the inside left alone. So the derivative of the outside is going to look like this. With the inside left alone is going to look like that. Okay, but now I have to multiply by the derivative of the inside. Okay, that's where this gets tricky. The derivative of the inside is actually going to require use of the product rule because the inside has two things multiplied together. Okay, I need parentheses over here. I'm going to take the derivative of the first, which is cosine, times the second, which is cosine, plus the first, which is sine, times the derivative of the second, which is negative sine. Okay, now they might simplify this and make this 1/2, 1 over the square root of sine cosine, and then maybe make this cosine squared minus sine squared.